Hello everyone, my name is Famelab and my major is biological sciences. Like many scientists and philosophers, I've been fascinated by a human mind, and I was curious how human consciousness appears. Unfortunately, we know little about the mechanisms inside the brain and how the different parts of the brain interact with each other. That's why it's important to explore and understand the human brain structure and the neural activities. Up to date, scientists and engineers, they created more sophisticated brain imaging techniques such as conventional light microscopes, two-photon microscopes, computer tomography, MRI, etc. Obviously, each of them has a unique principle and has its own pros and cons. However, there is a relatively new technique which is called PAT, and it uses the PAT stands for photoacoustic tomography, and it is possible thanks to a photoacoustic effect which was discovered by Alexander Bell in 1880. So this technique, it implies two sources of energy. First is light, which serves as an excitatory agent, and the second is ultrasound wave, which is the responding signal from the object. So there are some biological molecules inside our bodies which has some optical activity, which means they can absorb light, and through some processes they can emit the ultrasound waves. So this is used to image the brain. So here's the very basic setup for a PAT experiment. First, you place the object, some biological tissue, onto the table holder, and then you illuminate the object by near infrared light. So the light is absorbed by the tissue, and it emits ultrasound waves, which are transduced, which are detected by a PAT device, and further they go to the computer, and this data is used to recreate the image of a tissue. So the PAT has some advantages over other imaging techniques. First of all, it has a deeper penetration depth, it is harmless, and also it doesn't require some exogenous contrast agents. So for example, the hemoglobin, the lipids, or melanin, which are intrinsically in our bodies, can be used to image the tissue. And also I want to briefly mention about the implementations of PAT. First, it can be used to diagnose cancer. It can be used to image the brain vasculature. You can see the networks of blood vessels. And also you can use the PAT for activity assessment. So you can see how much is active the certain parts of the brain. So as a conclusion, I want to say that PAT has a huge potential, and it may probably become a very useful tool in brain studies. Of course, right now it has some challenges, it has some constraints, but I believe that after some time, after people solve these limitations, it can be indispensable tool. Okay, thank you for listening.